Okay, this is part 2 of lesson 7-2, all about similar polygons, finding a scale factor, writing similarity statements. So here we're actually going to start doing some math now that you understand a similarity statement and a scale factor. So for these two triangles, they are similar, right? Each pair of polygons is similar. Find the value of x. So they've all been proportionately increased in size or decreased, right? So we started off with this guy. We increased it, and now we have this guy. We don't know what this hypotenuse is, but we know what the legs are, right? We know this hypotenuse is 10, and then I have these two legs, and I have to compare them to these two legs, right? So this looks like the shortest side, and it's from the 90-degree angle to this double angle. So here's this shortest side, 90-degree to double. So this length is x compared to this length, which is 9. So I'm going to write x over 9. That should be the same ratio, this side to this corresponding side, should be the same ratio as this leg to this corresponding leg. So 8 to 12. Right? So now I have a proportion. I compared corresponding sides, x and 9. I took x, I increased it to 9 by a scale factor. I also took 8 and increased it to 12 by a scale factor. So how do I know what this side was before I increased it to 9? Well, this has got to be the same ratio as this, right? Because it's a similar triangle. I increased both by the same amount. So I'm going to cross multiply. I'm going to solve this, how I know to solve proportions. So 9 times 8 equals 12 times x. 72 equals 12x. Divide by 12, and I get 6 equals x. So before I increased this to 9, it was a 6. The ratio 6 to 9 is the same thing as the ratio 8 to 12. The hardest thing here was just identifying what the corresponding sides were without vertices here to label them by. Okay, let's do number 2. Now this looks like sort of like a trapezoid. Doesn't tell us the sides are parallel. That's what it looks like. So here, I've got all my angles marked congruent, so I can easily see what the corresponding sides are. So I've got this guy and this guy. These are corresponding. I have to solve for x, so I know these are going to be in a ratio, 4.5 over x. And that's equal to, and over here, I only have a 10 here. Over here, I have 2 numbers. Well, I've got to be able to set this ratio equal to a full ratio, right? I can't be missing any other numbers if I want to solve for x. So if I compared this guy, there's no number up here to compare it to, these corresponding sides. But if I compare the bottom, these two bottom sides are corresponding, and I have both the numbers. So 4.5 compared to x is the same thing as 10 compared to 5. Right? The ratios are the same. So again, this is a proportion. I'm going to solve them how I know to solve them, cross multiply. 10x equals 4.5 times 5. I'm going to do this the long way. I know 4.5 times 10 would be 45, so 22.5, I think. 22.5. And then divide by 10. X equals 2.25. So if this is 4.5, this is 2.25. All it looks like I did here was take this and divide it by 2. Half of 10 is 5, so half of 4.5 is what? 2.25. Okay, number 3. Same kind of thing. Got this 4-sided shape here. I've got all my angles marked congruent, so I can easily see what sides are corresponding, right? And I want to find one full set of corresponding numbers. So it looks like this guy and this guy. So I can write a ratio. These sides are corresponding. So in the first shape, it's 12. In the second shape, it's 18. That should be equal to these corresponding sides, right? In the first shape, it's x plus 1. In the second shape, it's 24. And I'm going to solve it the exact same way. I'm going to cross multiply. Might have to have your calculator handy, and that's perfectly fine. 12 times 24 is 48, and 240, 288, I guess. 12 times 24 equals 18 times x plus 1. 288 equals 18x plus 18 minus 18 from both sides. 270 equals 18x. Okay, divide both sides by 18. I know if I divide both sides by 9, I get 30 equals 2x. And then if I divide by 2, I get x equals 15. So x is here is going to be 15. And 15 plus 1 is 16. So this side would be 16, this side would be 24, right? So x equals 15. I ran out of space here. X equals 15, which would mean this side would be 16, this side would be 24. 16 over 24 should be the same ratio as 12 over 18. This one in green. I try and change the colors up so they don't like run together because I write close here. All right, so I've got my triangles. They've got these two sides. Remember the third angle theorem in a triangle? If two of the angles are congruent to two angles in another triangle, then automatically that third angle has to be the same. So 1, 2, 3, 1, 2, 3. Okay, so we're going to compare these two sides and these two sides. So if I compare the bottom, 40 over 30, that should be equal to the sides. X plus 15 over 18. And I can cross multiply. It's probably easier to do with a calculator. 40 times 18 equals 30 times x plus 15. 440 times 8 is 300, 720, I guess, equals 30x plus 450. Doing this without a calculator, so y'all check my math. I know y'all let me know when I get stuff wrong. I'm human. Minus 450 minus 450 is 0, and 12 minus 5 is 7. 6 minus 4 is 2. So it should be 9. X equals 9. So if this was 9, 9 plus 15 is 24. 24 is slightly bigger than 18. 40 is slightly bigger than 30, so sounds good to me. 24 over 18 should be the same as 40 over 30. Let me know if I'm losing you anywhere. All right, last problem, word problem down here. Number 5, if ABCD is similar to PQRS, find the scale factor of ABCD to PQRS and the perimeter of each polygon. All right, so we're comparing this guy to this guy, right? They're similar, and it tells me what sides are congruent, so I know what's corresponding, right? So I can say, let's see, this top is 20, so the bottom is 20. This side's 14, so this side's 14. This is 25, so this is 25. I don't know what these sides are. So I'm going to compare this bottom to this bottom, 20 to 25, and that should be equal to the side to this side. So 14 over, I don't know what this side is, that's just x. So I can cross multiply now and solve. 20x equals 25 is 250, and 25 times 4 is 100, 350, I believe. 25 times 10 is 250, 25 times 4 is 100, 350, yeah. And then 2x equals 35, so x equals, what's half of 35? 17.5. So this side should be 17.5. Okay, so it said find the scale factor of ABCD to PQRS. I guess the scale factor is the 20 to 25. So scale factor equals 20 over 25, which if we simplify that, I can divide the top and the bottom both by 5. I get 4/5. So my scale factor is 4/5. For every 4 units here, there are 5 units here, right? And if I wanted to find the perimeter of each, here, 14 and 14 is 28. 20 and 20 is 40. 28 and 40 is 68. That's my perimeter. Here, 25 and 25 is 50. 17.5 and 17.5 is, what's 18 and 17? 35. So that's 85. And honestly, the ratio should be the same. If this is 4/5, then the perimeter, this to this, should be 4/5 as well. 68 over 85 should be about 4/5 as well. Make sense? The whole ratio of these sizes to these sizes, everything should be proportionate when these are similar. Because literally I just took the shape and enlarged it a little bit and got this guy. Right? So from here to here, that's 4 to 5, 4/5. Okay, questions? Let me know.